Good morning, everyone, and good to see many of you guys again. As Zeist mentioned, my name is Yan, and I often go by the online alias of the Burning Monk because I'm a massive fan of Rage Against the Machine, best band ever. As for Elm, my adventure with Elm really started a couple of years ago, back when it was still describing itself as this functional reactive language for doing interactive web applications. So at the time, it was a bit of a champion for the whole functional reactive paradigm, but like everything else in the industry, things change sometimes rather drastically. So if you fast forward to today, FRP is no more, and in the ashes of FRP comes the Elm architecture, which is a way how you should structure your Elm application, and is to Elm what OTP is to Erlang. And if you cast your mind back to Thursday, before all those parties that started, Jack did a really good job in explaining what Elm is all about, why it's interesting, and why you should spend time learning it. So I'm not going to repeat the messages here. Instead, I want to take this opportunity and really give you a flavor of what it's like to be coding in Elm, but by actually writing some code in front of you. So may the demo gods be with us. But let's have a quick recap of what the Elm architecture is. Well, from a coding point of view, you start with a union type that models the different states your application can be in, and then you have another union type to define the different reasons for that state to change. You specify what the starting state is, and interestingly, you return a tuple, which also includes a command, which is how you do side effects in Elm. In this case, when the side effect is finished, it will yield another instance of the message type that we have defined so that you can trigger state change. And of course, you're going to need an actual update function to do the actual state change, taking into account the current state, as well as the message that has been received. But notice that we are not actually managing the state ourselves anywhere. So that's managed by the Elm architecture itself. We just have to say, hey, here's the starting state, and then optionally a message to trigger some state change after initialization is complete. So by this point, I'm sure all the Erlang and Elixir developers in the audience is having a collective deja vu moment, because this is very similar to how Gen Server works in OTP. And that is not a coincidence. The decision for how Elm architecture works has been heavily influenced by the Erlang community, what happened in the Erlang OTP as well. But as well as returning a new state, we can also trigger some side effect with the update function, which of course, when it's complete, is going to send us back another message to do further state change. We can also subscribe to external things happening by subscriptions. So this is where you want to listen to keyboard strokes or WebSocket events, etc., etc. Again, that's going to trigger state change via the same message type that we have seen many times already. And whenever the update function returns a new state, is then automatically passed to the view method function to then render into HTML. But notice that our HTML type is also generic to the same message type that we keep seeing over and over, because this is a very important part of our application in terms of deciding what the reasons are for state changes. So as people are interacting with the view, they can then trigger additional state change via the message type. And we wire everything together using the HTML type from the HTML package, and that completes the whole cycle. And as Jack has mentioned already, you can actually nest this as many levels as you want, so that you can have a component-based way to approach to develop your web applications. And before we dive into the demo, just a quick recap of the syntax. This is how you create a new record or object in Elm, which are immutable. So you have to use the clone and update semantic to return a new version of some object you've got. You can create a type alias for objects of a particular shape. You can also use a union type to model branch cases within your types. As for the actual demo itself, we're going to build a game of snake. And the snake is going to start with 8 segments for its body, and it's going to be moving towards the right of the screen. And then you can use the ASWD keys to change direction. Depending on which direction the snake is currently moving in, you can turn left or turn right. And to give you the illusion that the snake is actually moving on a screen, then for every frame, we're going to work out, based on its current direction, where the head is going to be. And then we're going to trim off the last segment of its old body and attach what's left to the new head, so it looks like snake is actually progressively moving. And occasionally, we're going to spawn a Sheree, and when the snake's head touches the Sheree, then it will eat it, and you grow its body by one segment. So pretty simple. And with that, let's dive into Visual Studio Code. Okay. So I'm obviously inside Visual Studio Code. I've got a bunch of code snippets that helps me generate the template. In the interest of time, of course. So this is pretty much the standard template that we saw in the slides earlier. I'm going to start with the not started state as the default for our application. And as for the messages, we are interested in keyboard press, in which case we want to track the key code that's been pressed. And we want to track the time, so which means I need to bring in a few more packages, exposing. Oops. Okay, and when the application has switched to the started state, we also need to track the state of the snake, which we will now model as a record alias. Funny, when people watching you type, you can't type anymore. Snake is going to have a head, which is just going to be a position. And it's going to have a tail, which is just a list of positions. And then it's going to have a direction, which is something that we would create later. And the position, in this case, is just going to be the X and Y positions that the coordinates where we're going to draw is segment. And whilst we're here, let's create a helper function to take an X and Y coordinate and return a position object. And since all we're doing is turn it into two values into a tuple, we can use the comma operator to do that. And then let's define our direction type, down, left, and right. Is everyone reading this code okay? Is this too small? The guys at the back, is this okay? Great. Okay, so we've modeled our application. So now let's see what subscription we're going to need, which is going to depend on the current state the application is in. If it's not started, then we're going to want to listen to keyboard presses. And we're going to forward the key code to the key press message type we defined earlier. Otherwise, if the game is in the started state, we don't care about snake, so we use underscore for wildcard. And in this case, we can listen to both the keyboard press as well as time. So if you want to run the game in say 20 frames a second, then every frame is going to take 50 milliseconds. It's going to be 50 milliseconds apart. We pass that to the tick function. Next, let's do the view. But before we can do that, I need to bring in a few more packages. I know from doing this a few times already that I need these guys, color, and whilst here, let's bring text, and char as well. So for the view, I'm going to have a background, which I'm going to draw as a rectangle, and this function takes the width and height. So let's define those up top. Width and the height. Let's say use a 500 by 500, and whilst here, let's define the dimension, the size for the square we're going to use for the snake's body, as well as the radius for the Sheree that we're going to draw later on. So back here, it's too flow. And then we're going to make that background black. And then for the actual content of the game, it's going to depend on the state we are currently in. If it's not started, then what we want to do is just display a friendly text to say, press space to start the game. Otherwise, once the game has started, we have the state for the snake. So we will want to draw the head as a rectangle using the segment dimension that we defined earlier, and we fill that as white, and then we move it to where the snake's head is currently at. And then the tail is just going to be a snake.tail, which is a list of positions where we should draw. So we just transform them to a bunch of a list of rectangles, segment dimension again. But this time we draw them as fill them as yellow, so visually they're different. And then we're going to move them to that position. So for the content of the game, we're going to display the head and then the tail, and then we're going to put everything in a collage that covers the entire width and height that we've defined by drawing the background first, then the content of the game, and then we're going to just convert everything element to HTML. Okay, it's going to complain because, okay, it's looking for the text method. So guess what? I'm going to cheat because I've got the code snippet. All it does is just pretty formatting, so it's not that interesting. Now that we're here, let's start the Elm reactor. So what this is going to give me is the ability to, let's make this bigger, to then browse to HTTP localhost 800, and then this will compile my code. And then, as you can see, as I press state space, nothing happens because we haven't done any state transition yet. So let's do that. If it's not started, then we won't listen to keyboard events. When the key, I know for a fact that key code 32 is a space key. So when we're not started the game, someone press space, we're going to transition to the started state with some initial state for our snake with no additional side effects. Otherwise, we're just going to stay as we're not going to make any changes to the state. So now it's going to complain about not having that initial state for the snake. So let's do that, add that here. Initial snake is a snake, and init snake is going to have a head value as 0, 0, and then the tail is going to be reset 1, 2, 8. And then we're going to map that to x and y coordinates, which is the tuple. Y being 0, so that's on the same level as the head, and then the x value is going to go backwards, and then the direction is going to be moving towards the right of the screen. So when we've done that, this compiler is going to say, hey, you're not handling the started case yet. Fair enough, compiler, so let's do that. Once the game is started, let's capture the snake state. Well, okay, let's see the messages we can receive. Ooh, okay, and it's a key press. We're going to track the key code so that we can determine whether or not the snake is trying to, the user is trying to change direction. And of course, to do that, I've got another helper function, which takes the key code that's been pressed, the current direction, and returns a new direction. So we do that, snake.direction. Oops. So the new snake, so our snake is going to now have a new direction in life, and then we're going to return that in a started state with a new snake and no additional side effects. As for the tick, we are just going to leave things as they are for now, so that go back here, we refresh, we found a compiler error because I forgot to bring in the code snippet. Voila. So we're going to use the 4 keys A, W, S, D to control the direction. So now, that's not working. Okay. So, oh yeah, it's working, but it's just drawing the initial state. Ah, that's right, of course. Sorry, I jumped the gun because when time passes, we actually just returning the current state. So it's doing what it's supposed to, but I just moved it forward. Well, I moved forward mentally. So time has passed. Now we need to work out a new position for the head of the snake. So the segment is going to take the snake's head, and the current direction is moving in. And to avoid further compiler errors, let's just bring them in now. So this guy is going to take where the position is for the head and then the direction, and then work out a new position for the head. And then the old body, we're going to create that by surgically attach the old head to the old body, or the old tail. And then for the new tail, what we're going to do is, as we said, we're going to take it from the old body, and then we're going to trim all the last segment off. Length of the body, -1. So the snake is now going to have a new head, and it's going to have a new tail. And then we're going to stay in the started state with the new snake, and no additional side effects. So now that when we do and refresh, we've got the user control implemented, but there's no, game rule yet. So to do that, I've got another helper function. See, this is how I get it done within 20 minutes. to work out whether it's game over based on taking in the new head position and new tail position. So we'll call that guy is game over with the new head and the new tail. And then we're going to say if it's game over, then we're going to switch back to the not started state. Otherwise, so we're going to stay in the started state. So now when you hit the wall, it's going to be game over, or when I get the snake to sort of go into his own body, then it's game over as well. So next, let's add the Sherees. We start by defining what a Sheree is, which is just the XY coordinate where to draw the circle. But we don't always have it, so we make that a maybe. So when we do that, the compiler is going to tell us, hey, there's a couple of places I need to update, including the view logic, which is now need to take into account whether or not there's a Sheree in the state. If there's nothing, then we just draw the snake like we did before. Otherwise, we have a position now to draw the circle with. We draw it with the Sheree radius that we defined earlier, except I mistyped that. Sheree radius, and we're going to make the circle white, and we're going to move it to that position, and then we're going to draw the head and tail of the snake. This is another compiler error there. Yep. So when we first go into the started state, there's going to be no Sheree, so nothing. And after that, we can capture the Sheree as a local variable. And it looks a bit scary. This is because it's expecting a Sheree here, but because you're not provided it in a few places, then that is going to interpret that as a partially applied function that's waiting for a Sheree. So once I've done that, save, everything is back to normal. So now when I refresh, still no Sheree because we actually haven't done the logic to do that yet. To do that, we also need to bring in the random package, module. And the way to do it is kind of strange and takes a bit of getting used to. So what we're going to say is, if there's no Sheree right now, then what we're going to do is we're going to stay in the started state with the new snake and the current Sheree. But additionally, we're going to generate some random value. And as you can see from the signature of this method or this function, it takes a generator, and then the result of that random value is generated needs to then get mapped to the message type we've created, which means that we're going to have to create another case for our message type. Let's call it spawn, and then we're going to have to create a random generator later. So let's think about what random numbers we need to generate. We're going to need to generate a probability value so that we don't, whenever Sheree is eaten, it doesn't just get spawned right away. And we also need to generate the random positions. So we're going to need the randgen value that is a random.generator of type float and position. And let's just do a random generator for positions first, which is just a tuple, which we can generate with random.pair. And two separate random generators of flow of 0 to 1. A bit lazy, let's copy and paste. And then we do the same thing here, random.pair. So 1 for the probability, and then we're going to take the random position. Okay, so now it's going to complain that we are not handling this new spawn case that we've just created. Okay, thank you, compiler. So we're going to capture that. Those random numbers that we're going to generate with pattern matching. And then we're going to say, if chance is less than, say, 10% of the time, then what we're going to do is we're going to spawn a new Sheree with another helper function I've got, which takes the random x and random y values I've created. And I'm going to go back into the started state with the snake, and this time a new Sheree with no additional side effects. Otherwise, everything stays the same. So of course, he's going to tell me that I don't have a spawn Sheree method function yet. So all this guy does is it takes the value between 0 and 1 for both width and height, and then work out the actual x and y position to return. So now that we go back here, refresh, you can see we're generating a Sheree, but we can't eat it, which is really annoying. So let's do that. Let's ask ourselves, do we eat a Sheree? Well, that kind of depends if there's a Sheree to speak of. If there's nothing, then of course we didn't eat it. False. Otherwise, we have a position to work with. So we check if it overlaps with the snake's head, and let's bring that in, is overlap. What that takes is the snake's head's position and the position of the Sheree. And then we're going to say a new Sheree is going to depend on, did we eat the Sheree? If we did, then there's nothing left. Otherwise, oops, clamp. Otherwise, the Sheree state stays what it is. And then we're going to have to use that to other places. So now, refresh. We've got a Sheree that we can conveniently eat, but it's not growing our snake yet. So one more change. If we ate the Sheree, then we're going to take the old body as a whole. Otherwise, we're going to trim off the last segment. So now, if I refresh, hopefully you will see soon that the snake's body is visibly longer. Are you convinced yet? Yes? Okay, cool. All right, we still got like 8 minutes, I think, so let's do a few more things. So let's add the support for a score. And of course, when we do that, the compiler is going to say, you missed a few things here, mister, including the score, and you're going to display it. So I've got let's just reuse that text helper function I created earlier. It's all planned. And then we're going to display that as part of the game content. And when we go into the starting state, we're going to start with the score 0, and after that we can capture it. But remember, we have to pass it along at every opportunity. Except here now let's work out what the new score is, depending on did we eat the Sheree. If we did, then the score is going to be incremented, otherwise score stays the same. And then we just pass that forward. We refresh. When we eat the Sheree, let's see, yep, score goes up. And since I haven't seen the 5-minute mark yet, so let's do some more things. What about if we want to play sound when the snake eats a Sheree? That'd be pretty cool, right? To do that, I need to do JavaScript interrupt because you can't actually do sound in the Elm. So you do that via ports. So here I define a port where I can tell JavaScript to actually, hey, do something. And what I'm going to do here is, so instead of just generating a random number, what I'm going to do is I'm going to do two things. I'm going to generate a random number, and then I'm going to say, oops. And then I'm going to say, okay, if I ate the Sheree, then let's play some sound. Otherwise, do nothing else. Okay, and now it's going to complain about something. Right, you can't define a port inside a normal module. Instead, I need to define this as a port module. I think the idea is that you will capture all the interrupts at the top level, and then if you've got nested components, you capture them at the top level, and then you forward them on via messages that's been defined in those nested modules. But once I've done this, because I'm doing interrupts, so I need to have support in the JavaScript side as well, which means I can't use the Elm reactor. So instead, I need to compile my Elm code to JavaScript so that I can then import it, and then from the JavaScript side, I can initialize it, embed it, and then I can access the port I've defined, and I subscribe to it. In this case, I'm going to play some MP3 I've downloaded from the internet. And so to compile it, you can run the, you can run the Elm make. You can see I've done it quite a few times. So once I've done that, I can then go to, I've got it here somewhere, and go to this guy, refresh. So now, let's hope sound works. Pew! 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 Thank you. So that's a fully working game of Snake in about 20 minutes, which is pretty good, considering that it took me more than 20 minutes to wake up this morning. So that's a very quick demo. I appreciate that in practice, you're going to be doing a lot more in your Elm code, including talking to some HTTP, some cloud-based services. But to do that, there's established the mechanism to do that in Elm with task. And you have a very similar mechanism in terms of that using a side effect, which is a command with a message, and then trigger state change. So And as well as talking to other JavaScript libraries. So for example, if you want to integrate with Firebase, which would be a quite cool extension that you should do to my project, you can find on the GitHub. You can then have a multiplayer mode, for example, or you can implement some Twitter client, for example. Be creative, be wild. And you don't have to download anything to play around with Elm either. Just go to elm-lang.org/try. Then there's an online editor you can play with. And there's an excellent guide, which only takes about an hour or two to read. That will get you from pretty much knowing nothing about Elm to actually being able to start doing some stuff. Because the language stuff is quite small, there's very little syntax to learn. There's some things you need to learn around how the Elm architecture works, but once you get your head around it, it's quite a sustainable model for building more and more complex applications. With that, I think we've got a few minutes for questions, if you've got any.
So we saw you were passing the states all the way down through your components. And is there a way to kind of bind it? And in Redux there is provider and connect, and you can just get state in any depth that you are, and you don't need to pass it around?
So the way to do it in the Elm architecture is that suppose you've got a nested module that defines its own messages and model and how state transition should happen. And then what you can do is in another module, you can then import that module so that you have access to the things that's being exposed, such as the messages. So then when you receive things, you can, from the view, you can then map that. You can just forward it on to the message, because at the top level, you don't understand what that particular message is for, say, one of the. Also on Twitter, you've got recommended users. So if someone pressed, I'm going to follow someone, that's going to register a command with a message type that's defined in the nested module, which the top-level application doesn't understand. All it does is you then forward it on to that imported module. That's how you can start nesting your application in the Elm architecture. Does that answer your question? Okay, cool.
Okay, thank you.
Thank you very much.